Concavity. Your grade 6 science class. With lenses, like concave up, concave down. You're grade 6. All right, girl, it's still to be math. I know it's probably going to take another 2 weeks of these other math. We have a whole other unit we need to still practice. Concave down. Between A and B. Make sense? GMS is concave up between points A and B. If you have a graph of the points of the curve comes from below, lies below the tangent line, it's concave down. If it lies above the tangent line, it's concave up. So the tangent line that we're talking about is the horizontal line with slope of 0. So when you're 0, it's 0. Okay. Now, I feel like we're not ready yet. We're not. I'm talking over you is what I just decided I'm going to do. So, slopes in the tangent line increase left to right. Okay? First derivative is increasing on the interval. Therefore, the derivative and second derivative are both positive. We're going to copy so again, first derivative, that tangent line has a slope of 0. So derivative is equal to 0. It lies below it. It's concave down. Concave down, the slope decrease from left to right. The first derivative is decreasing on the interval. So therefore, the first derivative and second derivative are both negative values. Okay? Got it. Perfect. Concavity. So if the second derivative is greater than 0 for all x values on the interval, then the graph of the function is concave up. So it's kind of like a second derivative test. If the second derivative is negative, less than 0 on the interval, it's concave down. So negative values mean concave down, positive values on the second derivative mean concave up. Critical values of the first derivative separate the increasing and decreasing intervals of the function. We know how to do that. So the zeros of the second derivative will indicate the points where the concavity changes. Okay, these are called points of inflection. So now you're going to have critical values, you're going to have points of inflection. So we're adding on to everything. All right, so if we switch to page 2, if we look at this graph, at negative 3, what's the slope? 0. So we know that that's a critical value, right? We know negative 3 is a critical value. We know that 0 is a critical value. Positive 2 and positive 4 are all critical values. So that's your first derivative is equal to 0. So if we look at negative 1 to negative 5, so we're looking from point A to this unknown point here. Which way is our graph opening? The concavity is down. Okay. From negative 1 to positive 1 is opening up. The concavity is up. From 1 to 3 is up. And then from C to 5, it's down again. Right? So what do we know about the derivative here? The derivative on these values. Second derivative is going to be negative. Here it's going to be positive here, here. Okay, got it? That's the rule. All right, so now you're going to figure out here the graphs are concave without graph. Because you guys don't need any graph. All right. So step 1 for this process. I think I'm recording. Step 1 for this process. If you given a function, it's a cubic function. So we know what the end behavior will be as a positive cubic function. So it will be 1 and 3, up in 1, down in 3, right? Perfect, that's good call. So step one, solve for the first derivative and solve for your second derivative. So we'll do the first derivative first. So we're going to have 6x squared plus 18x plus 7. Second derivative, 12x plus 18. So what's the most? So I'm using the second derivative to find where my concavity changes. So we have to find our inflection point. And how do I find my inflection point? What do I do with the second derivative? Set it equal to 0. So I'm going to take my second derivative, set it equal to 0, and I'm going to solve. Okay, I need a coordinate pair for my inflection point. So that involves a coordinate pair. So sub it back into which equation? The original, because we're looking for the inflection point on that cubic graph. So it's going to go back into the original. You guys trust my math? Hopefully. Wow. I made a ton of mistakes and yet you all still trust it. So my possible inflection point why did I call it possible? Not my inflection point. Anybody have an idea? Why is it that? Because remember, sometimes it doesn't change. Like if we have that drag, it's either opening up or opening down. So I have to make sure that my concavity changes in order for it to be a true inflection point. Okay. So step 3, nice and easy. This one, remember why. What's going to be my critical point on my number line? Negative 1.5. So a value less than negative 1.5. I'll pick negative 2. What's a value greater than 1.5? 0. So here's the question: what am I substituting into? I picked my value, but what am I substituting into? Remember, I'm looking for the concavity, and concavity deals with my second derivative. So I'm substituting into the second derivative. So if I put in negative 2 into 12, 18, what do I get? I get some sort of negative number, right? Negative 4. So this is going to be negative here. If I substitute in 0, it's going to be a positive 18, so this will be positive. So what does this mean? Now we're going to make, it did change concavity. It did change concavity, so this actually is an inflection point. It's not a possible. We know it's an inflection point now because we have changed the concavity. Does that make sense to everybody? Okay. Anyway. Okay, I'll slow down. We said it was a possible inflection point because I had to make sure the concavity changed, which was step 3. Right, so it's changing. It's an increasing function, it's increasing to a decrease. So the concavity is changing. So what we know is, so step 4 is making a statement about concavity. All right, so where is the graph concavating down? Where it's negative. So let's make a domain statement about it. F of x is concave down where? Inclusive or non-inclusive? Right. It's that point where your like it's going to be zero, so your concavity doesn't exist. Your second derivative is zero. Right? We know this because the second derivative is less than zero. And then where's the graph concave up? Negative 1.5, positive infinity, because we know the second derivative is greater than zero. Okay. We know it's an inflection point because the concavity changes, and what at negative 1.5 is the defined point. That makes sense to everybody? The point actually has to exist on the graph. It can't be like it has to be continuous, like it has to have a point in order to be an inflection point on that function. Make sense? Clear as mud? Perfect. Woo! Okay, now we're sketching polynomial graphs for realties. No. So this is grade 12, but better. So this is your pre-cal, but better. Okay, so in order to sketch polynomial graph, you need to run intercept, you need to x-intercept, you need to maximize your minimums, your inflection point, and your concavity. So in grade 12, we did our y-intercept, our x-intercept, and our concavity. We did in grade 12 pre-cal. Now we're writing out in all of them. So going back to pre-cal grade 12, so it's not that far away from you. But to determine the x-intercepts of the one we just did here, how am I going to do that? Synthetic division. So I'm looking for the factors of -6 that are going to go and be a factor of this. So I know that -6 would be -1, +6, +1, -6, -2, +3, +2, -3. Right? Those are all my factors. You guys remember this? Yeah. That doesn't you pick it from the factors list. Don't pick 5. So we wouldn't, okay, so we wouldn't pick 0 because it's not a factor. You always take the factors of your constant, and then you start picking from this list. Yeah, it's kind of. Oh, yeah. Okay, good. I know that. Here's what I'll tell you. You guys need to. So we tell secrets and extra help. We give away all of the secrets. Okay, so now you know. Moving forward, a little late to the party, but now you know. Yeah, if you know this, you always have another number. Perfect. If I substitute 1 in there for x, so f of 1 is So we know that that's not going to work. So that doesn't equal 0. What's another one? Pick another one. So you need a negative, right? There's too many positives in there. If I put a negative 1 in there, ooh, this should be a square, sorry. So negative 2, positive 9, so positive 7, minus 7, 0, minus 6, not going to work. So let's go for negative 2. It is. This one actually works. So thanks for having faith in our math. That one actually works out to 0. So what do we know? If we substituted in x equals negative 2, so x plus 2 synthetic division. Now, I think I do it differently than Thompson. So this might screw some of you up, probably a lot of you, probably all of you. I take it as a positive 2. On the inside, do you do positive 2 or negative 2? You do, okay, good, you all the same way. Because there's another way where you can negative from negative and then no, okay, 2, 9, positive 7, negative 6. Oh, I got a little crazy with my so the 2 comes down, be 4, it'll be 5, it'll be 10, so negative 3. So this is my remainder, constant x squared. So 2x squared plus 5x minus 3 is my other factor. And then you can factor this, which I'm sure you all continue in your head. My third factor is x plus 2. So we're going to answer this. Right? Okay. So that's what you need to know. Alright, so the domain range, the domain of a quotient function is always XCR unless otherwise stated. The range depends on the function degree, automotive power range of YPR. Even degree polynomial functions with a positive coefficient will have an absolute minimum at one of its relative minimums. And even degree will have an absolute max at one of its relative max. Right. So you need to remember that from grade 12. Some of you do better than others. We'll just finish. This will be a question on your assignment for sure. I'm pretty sure it's on your quiz, and I'm pretty sure there's one on your test. Just FYI. So it tells you everything. It tells you relative minimum, relative maximum. I'm asking you to graph this based on the information given here. So you have to be given a function. So what I would do is I would plot any points that you have. You're going to plot all those points. Just dots on a graph. And only those on degree. How? I need you to go. So I need you to read. Sorry, emotionally abusive is what I'm doing. -3 is right here, there minus intercepts, negative 0.5. So this is our one that we just did. We didn't do the relative max, the relative min, but this is all the information for that function. Okay, so it says it's concave down between negative infinity and negative 1.5. So this right here is my inflection point. So if it's concave down, what do we know from negative infinity to negative 1.5? Which way is it opening? Down. And your gut should probably indicate that. So if I were to do my concave down, this is the exact point where it changes from being concave down to changing to concave up. So it's saying from 1.5, every other point is now going to be opening up. You know, it's an odd function with a positive coefficient, so that it's going to be up in 1 and down in 3, which makes sense. So we are going to continue down. So the difference between grade 12 pre-cal and calculus is now we know where the height of our maximums and the depths of our minimums. That's not too bad. Does it satisfy a range and domain? Yes. If I have to do the domain range for that graph, you would say negative infinity, positive infinity for both. Okay, we're going to do one from scratch on the next page. Okay, so this is grade 12 pre-cal plus calculus, so I'm expecting a beautiful polynomial function graph. I will show you that this is the information I did to graph it. None of that's hard, but we need to do all of it. So, what do we know about the behavior of this graph? 1 and 2. So up in 1 and 2. Up in 1 and 2. That's great. So the next thing, what's my y-intercept? So I have that. The next thing I'm going to do, so you're essentially doing the list from the example before. Okay. So the next thing I'm going to do is I'm going to do the x-intercepts. Do you want me to give you the factor? 1. X equals 1. So x equals 1. So we substitute that in there. You're going to get 1 minus 5 plus 4. Guess what that gives you? 0. So x minus 1 is a fact. Now I'm going to do synthetic division. This one I think I screwed up on the first time I did it. Oh, I didn't. 1, 0, don't forget you got to put 0 in for ones you don't have. 5, 0, 4. It's negative. Is it? Oh, so that's, so there we go. Thank you. That screws everything up. So 5 minus the negative 1 is going to be negative 4. So it'll be a positive 4, negative 4, positive 4, 0. So then this will be my constant, my x squared, and my q. So we got to do this again. Right? So we're going to have to do it again. So what's a factor? Negative 1. So negative 1, positive 1, positive 4, negative 4. So we know that x minus 1 is another factor. So we have 2 of them. So what's that going to result in? Oh, it's like you guys are doing this. X minus 1. Oh, this is, oh yeah, sorry, this is plus 1. This is a negative 1, sorry. So that should be plus. So 1, 1, negative 4, negative 4, 1. 0, 0, negative 4, 0. Oh my goodness. So now I've got x squared minus 4. Difference of squares, right? So all of my factors are x plus 1, x minus 1, x plus 2, x minus 2. So my x-intercepts will be plus minus 1, plus minus 2. Remember when that was started? Well, you didn't have to take the factors as a constant.
I just knew.
You just knew. You knew.
I didn't know.
Okay, perfect.
3 on 10 we're recovering we're recovering.
And it's highlighted those because those are points we're going to plot. Okay? I highlighted them because those are points we're going to plot. So what do we do now? We find the relative extremes. So relative extremes deal with what derivative? First. Right? So we have to find our critical values, we have to find our relative extremes. We're not taking minutes. Because right now we just have the dots on the x-axis. We get your data kind of going down. So first derivative. I don't know what I'm going to. So my first derivative is going to be 4x cubed minus 10x. What am I going to do? I'm going to take out, I'm going to 2x. And I'm left with x squared minus 5. Right? Thanks for having my back there. So I'm going to set that all equal to 0. So one's going to be, this one's going to be equal to 0. And the next one is going to be what? Plus or minus the square root of 5 over 2. I did some non-time there. I did some rearranging along step equation. So x is equal to plus or minus, what's that here? 1.58. So what do we do with that jump? Another number line, right? Because I need to find out if it's a round to max or min. So I've got 0, I've got negative 1.58, and I've got a positive 1.5. I got 3 of them. So, question is, for these critical values, am I substituting into original or the derivative? Derivative. So at negative 2, if I put it into the derivative, what do I get? Do I get a positive or negative number? Negative. And I'm going to pick negative 1 here. If I put negative 1 in, what do I get? Positive. If I put a plus 1 in, it's going to be negative. And if I put a positive 2 in, it's going to be positive. So what does that mean for those points? So what's happening? Increasing to 0, increasing to 0, then decreasing. What's 0? It's a max. 0 is a max. Right? If I'm decreasing and then I'm increasing, then grab you guys. And if I am decreasing, then increasing, then again. Okay, I need coordinate pairs at all these points. Okay? This one's nice and easy to do. What's my coordinate pair here? 0.4. I've already found that point. Getting my highlighter out because I know I have to plot that point as well. And here am I substituting these values into original or derivative? Original because it's an actual point on the graph. At negative 1.58, it would be at negative 1.58, it's negative 2.25. And at positive 1.58, it's positive, nope, it's also negative 2.25. You guys tell me you trust my math, so this is what you did different than grade 12, grade 9. So what else do I need? Now we're moving on to our concavity. We need our, what are they called? Inflection. Inflection points. There's the point where the graph changes from concave down to concave up. You need your inflection points now. It's the exact middle. Inflection points, what do they have to deal with? The second derivative is going to be so set that equal to 0. There's going to be 2 of them. There's going to be 2 of them, and that would be plus or minus the square root of 5 over 6. Sorry, x equal to that. So x is equal to plus or minus negative 0.91. I'm assuming you guys are okay. Work out your math for you. Yeah, you okay with that? So bring the 10 over. 10 divided by 12 is reduced to 5 over 6. You're going to take the square root of it.
Plus or minus negative.
Oh, sorry. So there's the negative doesn't make sense there. There we go. Neither makes sense. All right. I got a little excited. I was moving on. So what do I do now with my inflection point? Gonna do the number line. So I have negative 0.91 and I have a positive 0.91. Okay, so a value less than 0.91. Okay, I'm okay with negative 2. If I substitute negative 2 into the second derivative, what do I get? Get a positive number. I don't care what it is, I just need to know that it's positive. If I put a value in between those two, like 0, you're going to get a negative. And if I pick a value greater, it's that positive 2, it's going to be positive. You don't have to do a lot of math here. It's a square, right? So what do we know? We know that the concavity is changing, right? So that confirms that these are inflection points. So I actually need to know where they're happening. Where do I substitute that in to find the coordinate? Original function. So this would be negative 0.91 and positive 0.54. And this one would be a positive 0.91 and a positive 0.54. Grab my highlighter again. I need to grab my inflection points. All right. Here we go. Now we have all of those. We are going to grab everything. So you guys just did all my math on my page. Your page should look pretty full. All right. I'll change colors just for the fun of it. So x-intercepts occurred at 1, 2, -1, -2. My y-intercept was at +4. I have, what do I have? I have relative maxes and mins to place on there. So, that is my relative max. My relative min is going to be at negative 1.58, just a little shy of that one, and at negative 2.25. So there, and I'm going to have another one over here. So I've graphed my relative max, my two relative mins, my x-intercept, and my y-intercept so far. Last thing to graph are my inflection points, and they happen at negative 9.1 and positive 0.54. Now I'm going to connect the dots based on my concavity. So the concavity up to my inflection point, from negative infinity to my inflection point, which way is my graph concave? We look at our list, it says positive in this section, so my graph would be opening up at this point. Which makes sense because a positive function will be up in 1 and up in 2. So, okay. Now where am I headed from here? Still up to my relative max, and then I'm coming down to my other inflection point. Now, we said between the two inflection points, the concavity was down because it's negative values. So we switch at this point to concave down. Here we switch back to concave up. So I will be looking at graphing for all those points. I'll be looking for relative masses, relative mix, inflection points, and I'll want to know where they are. So you'll have to listen for me. What? It was. It didn't do all of it.